السلام عليكم ورحمة الله وبركاته أبنائي وبناتي طلبة الصف الثاني الثانوي. You are welcome again with chemistry. Now we will illustrate chapter 5. Chapter 5 speaks about the representative elements in the molded periodic table. And representative elements, as we have studied in the first term, includes S block and P block. We will study some groups of S and some groups of P block. S block, we will study 1A group. Elements of group 1A are called alkali metals. Why they are called alkali metals? Because they form alkalis. When they react with water, they form alkaline solutions. Elements of this group are 6 elements, which are lithium, Li, its atomic number is 3. The nearest noble gas is helium. Sodium, Na11, potassium, K19, rubidium, Rp37, cesium, Cs55, and finally, francium, Fr87. Now let's speak about the abundance of alkali metals in the nature. First, sodium and potassium, they occupy the arrangement of the 6s and the 7s most abundant or the most common elements in the Earth's crust. Most important ore of sodium is rock salt. Its chemical formula is NaCl. So NaCl is a formula. Its chemical name is sodium chloride, while its common name is rock salt. What about potassium? The most important ore of potassium is potassium chloride, KCl, and also found in it is found in seawater. And we have carnallite deposits. Carnallite deposits, it is KCl, MgCl2, 6H2O. It is a mixed salt, consists of potassium and magnesium chlorides accompanied by 6 molecules of water. It can be in form of, choose the chemical formula of carnallite is, and they give you more than one formula. The right one is KCl.MgCl2 and 6H2O. Okay. The rest of elements are rare elements. For example, francium. Francium, it is a radioactive element, can be obtained from the disintegration of actinium. Actinium, it is a radioactive element. Its atomic number is 89 and mass number 227. When it is decayed, it forms francium 87 and 223 and helium, or here it's called as alpha particle. It is a radioactive element. We have 2 informations only about francium. It is a radioactive element and its half-life time is 20 minutes only. Now let's speak about the general properties of the first group elements or group 1A. The property number 1. All elements of this group are characterized by the presence of 1 electron in the outer level. And all of them ends with the structure NS1. And the presence of 1 electron in the outer level, we have some results as each one of them starts, or it is the beginning of a new period. Again, each element of this group is at the beginning of a new period because it is the first element in the period. The oxidation number of all of them is positive 1. Why? They have 1 electron. They tend to lose this electron during reaction, so they form positive ions that contains 1 charge, and their oxidation number is positive 1. Even with oxygen or even with hydrogen, they are chemically very active. Why? Because the ease of the losing of valence electrons. They have large size, so they have weak attraction force, so it's easy to lose their valence electrons. They are malleable metals. The metallic bond in them is very weak. Why? Because it contains 1 electron in the outer level. The presence of 1 electron in the outer level causes weak metallic bond. Why? As we have studied in at the end of the chapter 3, the strength of the metallic bond depends on the number of valence electrons. These elements, they have just 1 electron, so they form weak metallic bond. The weak metallic bond means low melting point and low boiling point. Okay, the first ionization potential is small. What about the second ionization energy? The structure is noble gas NS1. The first ionization energy makes it lose one electron, so it becomes similar to the nearest noble gas. So the second ionization energy, it will very large. Why? Because it breaks a complete energy level. Okay, atoms of this group have the largest known volume, and that causes the following. The volume of the atomic increases down the group as we go from up to down. The volume increases. Okay, so the attraction force decreases. Alkali metals shows the following properties. An increase in the radius of the atom decreases the force of attraction, as we said, and as we have studied. As the atomic size increase, the attraction force decrease. So it's easy to lose the electrons. This electron can be lost easily. Therefore, these metals are considered the highest electropositive and chemical reactivity. Give reason. Why? Because they have large size and low attraction force, so it's easy to lose their valence electron. Now, whether they are exposed to any energy, as the energy of light. If the energy of light is sufficient, is enough to lose their valence electron, and this phenomena is called photoelectric phenomenon. The photoelectric phenomenon means that the phenomenon of losing electrons from the outer surface of the metals when they are exposed to light. So they are used in the manufacturing of photoelectric cells. Photoelectric cells, we have two elements as potassium and cesium. Potassium and cesium are used in the manufacturing of photoelectric cells. Why? Give reason. Potassium and cesium are used in the making of photoelectric cells. The answer, because they have large size and low ionization energy, so it's easy to lose their valence electrons when they are exposed to light. Okay, and they have large size. What about their density? The density, as if you remember, equal mass over volume. If we have large volume, so the density will be decreased. So alkali metals have low densities. Why? Because they have high or they have large atomic size. These elements have very low electronegativity. The same answer, because they have large size and low attraction force. The property number 3. When alkali metals are exposed to heat or when they are heated strongly, they produce a specific light or a specific color, which is called the flame test. How can we do flame test? By bringing a platinum wire and dip it in HCl. Why? To clean the wire. Then dip the wire inside the salt. If the salt contains lithium, it gives crimson light. If the salt contains sodium, it gives golden yellow. If it contains potassium, it gives pale violet. And if it contains cesium, it gives bluish violet. Now, the question, how can you differentiate between lithium carbonate and the sodium carbonate? We can expose them to bonds in flame or by flame test. The lithium gives crimson light or crimson color, sodium gives golden yellow. Okay. They have high activity, so they are kept out of air and humidity. How we preserve or we keep elements of alkali metals under the surface of liquid hydrocarbons as kerosene. Give reason. Alkali metals as sodium kept under the surface of kerosene to prevent them from their reaction with moist or humid air. When they are exposed to air, what's happening? They lose their luster. Why? Because they are easily oxidized. Lithium only can react with nitrogen, forming lithium nitride. Again, if you remember, we said that in the class. If the salt contains no oxygen, its name is ends with I. If it is nitrogen, its salt is nitride. If it's sulfur, sulfide. Carbon, carbide. So lithium with nitrogen, it gives lithium nitride Li3N. Lithium nitride dissolves in water, forming lithium hydroxide and ammonia gas, NH3. Now the question is, how can you prepare ammonia from lithium? We have two equations. The first, lithium reacts with nitrogen. What is the product? Lithium nitride. Okay, lithium nitride dissolves in water. It gives lithium hydroxide and ammonia gas evolves. Okay, with water, they are very active elements, so they can replace the hydrogen of water. Why? Because these elements are very active, and as we have studied in the chemical activity series, the most active metal replaces the less active one. So they replace hydrogen of water, giving hydroxide and hydrogen gas evolves. Okay? This reaction is exothermic reaction. Exothermic means it produces heat energy. So the hydrogen will be burning. So the reaction is vigorous reaction, violent reaction accompanied by an explosion. Now we have a video shows that we now, if we have burning sodium, we have a burning sodium fire. How can we extinguish it? Can we use water to extinguish it? No. So the question is, why we can't put out fires of sodium by using water? Why? Because sodium is more active than hydrogen. So it replaces it, which burns with pop sound due to the heat of the reaction. And the equation is 2Na plus H2O gives 2NaOH and H2 gas evolved. And as we go down, potassium, rubidium, cesium, the reaction increases in vigorously, so the reaction is very dangerous. Now let's speak about the reaction with oxygen. When these elements are burned, they give three types of oxygen, or three types of oxides. The normal oxide, in which the oxidation number of sodium is of oxygen is -2, normal one. Lithium plus oxygen gives lithium oxide. The oxidation number of oxygen here is -2, so this is the normal oxide. Sodium with oxygen, it gives the sodium peroxide. The oxidation number of oxygen here is -1. Potassium reacts with oxygen. Potassium, rubidium, and cesium give superoxide. And the oxidation number of oxygen here is -1/2, as we have studied in the first term. Both oxides, peroxides and superoxides are oxidizing agents. Look, when we can say the compound or the substance is an oxidizing agent, if it reacts with water or with acids, giving peroxides and oxygen. For example, when sodium peroxide reacts with water or with acids, it gives hydrogen peroxide. Hydrogen peroxide H2O2 is an oxidizing agent. And if potassium superoxide reacts with acids, it gives both of them, hydrogen peroxide and also oxygen gas, and both of them are oxidizing agents. Okay, here Na2O2, sodium peroxide with HCl. gives 2NaCl plus H2O2, hydrogen peroxide, oxidizing agent. Potassium superoxide with HCl, it gives KCl, H2O2 plus O2. Both of them are oxidizing agents. Okay. We have a great importance of potassium superoxide. It can be used in the purification of closed atmospheres as submarines or airplanes or tunnels. Why? Because it can react with carbon dioxide, released from exhaled air, producing oxygen gas. Now we have a similarity between potassium superoxide and the green plants. Why? Both of them absorb carbon dioxide gas from air and giving oxygen gas that can be used in respiration process. Potassium superoxide, KO2, reacts with carbon dioxide, giving K2CO3 and oxygen gas. Okay. Now let's speak about the reaction with acids. But first, you must know that we have the normal oxide as X2O. Why? Because elements of group 1A are monovalent, while oxygen is divalent. So the normal oxide X2O. I want to say that or remember you by that. Peroxide, ion O2 negative 2. O2 negative 2. So the oxidation number of oxygen here is negative 1. Negative 2 divided 2 gives a negative 1. Okay. Now let's speak about the reaction with acids. They react with acids. They replace hydrogen forming salt. Na plus 2HCl gives NaCl plus H2 gas evolve. The reaction with hydrogen. They form hydrides. They form what? Hydrized compounds. Hydride compounds, they are ionic compounds in which hydrogen has oxidation number negative 1. For example, lithium with hydrogen gives lithium hydride. Sodium with hydrogen gives sodium hydride. So the question is, the oxidation number of hydrogen in sodium hydride is negative 1. We have a tricky question. The oxidation number of sodium in sodium hydride, you are expecting that I'm asking about the oxidation number of hydrogen, but concentrate well. I'm asking about the oxidation number of sodium. It's constant. It is positive 1 in any compound. Sodium positive 1 while hydrogen is negative 1. Okay. With halogens, they form halides. Sodium plus Cl2. Here is 2. It gives 2NaCl sodium chloride. K plus Br2, not Br, Br2. It gives 2KBr potassium bromide. The reaction with other metals, they form salts as sodium reacts with sulfur, giving sodium sulfide. Potassium reacts with phosphorus, giving potassium phosphide K3B. Okay. Now let's speak about the action of heat on alkali metals, oxygenated salt. Oxygenated salt, it means it contains oxygen. We have carbonates and nitrate. Look. Carbonates of this group are thermally stable. What's meant by thermally stable? It's difficult to be decomposed. They melt without decomposition, except lithium carbonate, which decomposes at 1000 Celsius degree, forming lithium oxide and the carbon dioxide gas. Now I repeat the question again. How can you differentiate between lithium carbonate and sodium carbonate? Now you have two methods. The first, by flame test. Lithium gives a crimson color, sodium gives a golden yellow. Now we have another method. By heating them strongly, lithium carbonate decomposes and the carbon dioxide gas evolves that makes lime water turbid or makes it cloudy. While sodium carbonate, it melts only. Now I can give you a question. Choose the what happened or the effect of heat on rubidium carbonate. Rubidium carbonate, it is from alkali metal carbonate. They melt. So it melts without decomposition. I'll give you some equations. You must choose the equations that said that it melts without decomposition. What about nitrate? They decompose partially, giving nitrite and oxygen gas evolve. This reaction is vigorous reaction. This reaction is vigorous reaction and accompanied by an explosion. So potassium nitrate is used in manufacturing of bombs. Why? Because it decomposes by heat and accompanied by explosion. Can we use sodium nitrate? No. Sodium nitrate can't be used in manufacturing of bombs. Why? Because it is a deliquescent substance. Again, deliquescent. What's meant by deliquescent substance? Deliquescent substance means it is a substance that can absorb water vapor from air. So we can use it as a drying agent. It can dry any atmosphere from water vapor by sodium nitrate. Why? Because it is a deliquescent. Deliquescent, it absorbs water vapor from air, so it can't be used in making pumps. Thank you for watching, and I hope you get benefit from this video, and inshallah we will solve the problems in the second session بإذن الله. شكرا والسلام عليكم ورحمة الله وبركاته.